Okay.
Hey, how are you
Okay.
doing today?
It's
It's about 1 a.m. in Beijing, right?
yeah. I'm in Chengdu.
Okay, I see. Yeah, it's pretty late. So thank you for sending your resume. We look at it. It looks really good. You seem to have a lot of system level experience, so we really liked it. That's why we're talking to you. So today, what I
Yes.
want to do is first describe the position so that we're on the same page regarding what this actually does, and we're sure that this is something that you're interested in. And then I want to go over, drill down a little deeper into your experiences, and then we can go over some technical questions. Um,
Okay.
Sounds good. Awesome. Sure. So the position that we're offering here is so we provide a CRM service, SaaS on the cloud um, for mid-sized enterprises. And one of the challenges we're facing is service vacation. So we have a CRM system is pretty complicated. So one giant application won't cut it. So we have a service-oriented architecture with a lot of services. And so we need someone who will join the middle tier team and help us develop the APIs as well as the individual services. The specific technology used will be all Java based. Um, and then the experiences we're looking for are actually just really strong software engineering skills as well as the fundamentals of computer science. We don't look for specific technologies. Does that sound good
Okay.
to you?
I want to say that I just know the C++ and not Java. Is
That's fine.
okay.
As long as you're a strong programmer, we believe you can pick up technologies fairly quickly. So we don't look at that very strictly.
Okay.
Sure, sounds great. So I'm looking at your resume right now. Looks like you are participating in a research project on a distributed data store called C-Store. Can you elaborate a bit more on what that does and what's your role in the team?
Can you speak loudly?
Sorry about that. Is that better?
Okay.
Yeah, tell me
Uh,
a bit
uh,
more about C-Store.
and slowly. Sorry. And slowly. Yes.
Sure, yeah, I can do that.
Thank you.
So yeah, please explain what is C-Store and what do you do in this project?
System. Okay.
That's right.
Uh, the system is a distributed file system in our in our lab, and is suited for the massive small field storage, and and yeah, uh, and
What's the difference between C-Store and any generic key value store?
between what
Uh, what are the unique characteristics of C-Store? Um,
is I can say that the difference between system and the Google file system. Can I?
sure. Please go ahead.
Okay. The Google file system is suited for the big files for appending operations, and and if if we if we store the small file in the GFS, it it must be very slowly. Yeah, and so we developed the system for store the massive storage, the small fields, and the difference is the most different things is about the metadata management. In GFS, uh, there are only one metadata server, and in our system there are we designed a cluster on metadata management, and so we can largely improve uh, the scalability of the whole system. Uh, can you can you can you understand
Mm-hmm.
it? Yeah.
Yeah. So you're saying that the master node system in GFS gets overwhelmed when you have too many individual files. So are you putting in a middle layer to in between the master node and the individual files, or are you just turning that master node into a cluster so you can handle more data, as in more files?
We do that in whole layer. We at the low layer we use the local file system such as ext4 or XFS, and we uh, we according to the database such as we use the level DB to storage the metadata such as using key and value pair. Yeah.
Mhm. Sure.
And the middle layer we use uh, and the upper layer we use the uh, consistency hash algorithm to locate the metadata into the into one metadata server.
Mhm. Uh, yeah, I see. That's a really interesting approach. So, what is the team that, can you describe the team that works on this project? What is your role in this team?
My role is the uh, is the I responsible for the metadata servers and the rubbish collection models and the pressure test for the whole system.
Mhm.
Yeah.
Uh, how do you collaborate with the rest of the team? Well, how big of a team is it? Is a professor leading the team and then a bunch of graduate students working on it?
Sorry, can you repeat it?
Okay, I was wondering, how do you guys collaborate? How do you work together with your other team members?
Uh, we just uh, firstly we uh, we have a lot of meetings to talk about to discuss the design of every models and we everyone can talk themselves thought and finally uh, we will have a whole design of the system and then uh, uh, each of them have one models and to implement it. Yes.
Sure. Okay. So if you're making design decisions as a group, what do you do when there are conflicts? Especially if you're favoring one design, but one of your teammate is favoring another design. How do you resolve that?
How can I resolve what? Uh,
Disagreements, design disagreements.
okay. Uh, if we have a disagreement about one thought, we will talk we will talk the advance and the disadvantage, and then we will agree with one decision, and if we make a decision, we will uh, implement it.
Mhm.
Yeah.
So were there any scenarios in which the team had a prolonged disagreement that weren't easily resolved by simply finding the obvious solution? Were there any situations where it was very difficult to find a whole team agreement?
Sorry, can you repeat it? Sorry.
Sure, sure. So just wondering if, because sometimes when you're working in a large team,
Yeah.
different people have very different backgrounds and form different opinions based on their individual perspectives. And sometimes conflict resolution can be difficult. So, well, I don't know what's the nature of your team. So I was wondering if you encountered anything similar to what I usually see, which is, two people have really strong disagreements, or the team is
Yeah.
divided into two camps. Um, it's fine if that just never occurs in your team. That may just be the case.
Uh,
Or did you ever have to persuade another team member of your opinions?
Of course, uh, if I disagree with someone, I will give my opinion, and I will talk the advantages and disadvantages of my opinion, and I will talk a lot about my opinion to them. Uh, if I'm right, we will go that. If I don't, uh, if I make a mistake, they will reject me. Yeah.
Yeah, okay, that sounds good enough. Um, yeah, so this system looks great. Uh, so you mentioned that you were responsible for garbage collection and load testing. So how did you perform performance and load testing?
Uh, we use the we use the we tested the whole systems in a cluster of 100 machines, and the 20 of the machines is the metadata server, and the others is the data servers, and and we will we I programming a load let me see, a load generator, and we will push a lot of pressure to the whole system, and we can test the CPU and the disk and the memory of the cluster, if and to find the bottleneck of the whole system. Uh, uh, and at the beginning, we found the bottleneck is disk, is a metadata service disk I/O, and we will make and we found uh, the bottleneck is local file system. So we dropped the local file system and used the key value storage engines such as LevelDB to change it, and so we solved the problem. Yeah. Uh,
What data did you collect in order to find out what the bottleneck was?
Sorry.
What data did you have to collect to find out what the bottleneck was? Uh, what kind of performance data do you
It's
gather?
the CPU percentage and the no, it's the disk percentage and the I/O throughput, and the I/O throughput is very low, but the the disk uh, percentage is very high. So there are a lot of random I/O. It's not good.
Mhm. So do you have like a system level logging system, and you aggregate in which collects information on memory, CPU, and disk, and then you aggregate it.
Sorry.
Um,
Uh,
I'm just wondering, what's your data analysis system to figure out the final numbers?
uh, you mean the final numbers?
Yeah. So what kind of data analysis system do you what data do you, so let's go down a level. So the data we're trying to collect are CPU and disk data, but what do they really look like, and how do we collect them, and how do we aggregate them, and just to figure out the ratios that we're looking for?
Uh, sorry,
It's
I
fine.
can't hear clearly. Yeah.
That's fine. It's an international call, so if you can't understand what I'm saying, just ask me to repeat it. Um, so actually, let's move on. I think that we're pretty good on this database. So it looks like you're doing some great work. That's awesome. I'm happy to hear that. So let's move on to some technical questions. So suppose that you have a server and there are a lot of requests going into the server. You want
Okay.
to, every time there's a request, you want to display the top 10 requests by latency. So the 10 requests that took the longest time ever. And then you also want to display the top 10 requests for the past hour that had the highest latency. So for the past hour, what were the requests that took the longest? And then you also want to display the 10 most recent requests. And for this, do not use logging, do not store all the requests on disks, do not use a database. How would you do this?
Sorry, can you write the keywords on the YY?
Sure.
Yeah.
Yeah, I can do that.
Thank you.
Sure.
Yes, sir. Mm. Okay, I will use the. Firstly, I think I can use a hash map to do that.
Mhm.
I can. Okay, let me see. What means the highest latency?
It means the latency means how long it took for the server to respond. So
Okay.
10 slowest queries. So slowest is the term we're looking for here.
I just can every time the queries come, I can load. I can write the latency into a heap, and if the max heap, and if the next request latency is high than the others, he will be insert and delete the smallest, and we can get the top 10.
Hmm.
Yeah, it's my thought.
Sure. So that's for the 10 slowest queries overall. But what about the slowest queries for the past hour?
Past hour. Okay. Okay. The past hour we can add a timestamp on the values, and if the if the clock is if the timer is out, we will delete it from the heap,
Mhm.
and we can get the uh, the data for the past hour.
Sure. So how would you implement this expiration mechanism?
Uh, okay, we can implement a heap, and then we use the uh, timer to we use the heap and the timer to to implement it.
What do you mean by using a timer?
Timer is timer is just the Linux AI, and can use it or not. Hello.
Hello. Yeah. I think I lost you for a little bit. It's good now.
Uh, I can't use it. Is right.
Well, yes, you can. But let's go down a level. So from a code level, how would you implement this? Almost like what kind of data structure would you use to keep all the requests with their timestamps? And then how would you go through this data structure to delete all the requests that have expired?
Uh, I can. Uh, it's just the data structure is just a heap, I think, and it's very. simple. We can add data and delete data and get the top 10. As for the past hour, we can add a timer on every value. If the timer is out, is expired, it will delete it from the heap. Out. Can I speak clearly?
Sure. Well,
Yeah.
so how does each request know that they're expiring? Um are we traversing through the entire heap to see whether the timer has expired, or are we creating a separate process or separate thread that takes care of each single request? Um,
Uh,
how are you using this timer to figure out which requests we need to remove from the heap?
we set the expired time is 1 hour. If
Uh,
the one yeah,
yeah, sorry, go ahead.
and if the 1 hour if the timer is out, it will be deleted. Uh, 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 it will be deleted. Uh,
What deletes it? What mechanism looks at the timer, realize that it's out, and then does the deletion?
uh, Solution. We can use a uh, we can use a list to traverse them. We can use a linked list uh, uh, to traverse them. The links the linked list is response and the 1 hour elements.
Hmm.
And if uh, it's just like the LRU cache.
Hmm.
Yeah, we just to keep the 1 hour data in the linked list, and yeah.
Uh-huh. Sure. So if we have a linked list, then we have a mechanism to remove the nodes that, well, requests that are older than 1 hour. After removing them, how do we figure out what is the new top 10? The new top 10 may be affected as time goes on, or it may not be affected, depending on whether anything in the top 10 is expiring.
Because we use the heap and the linked list, so because the heap we can get the top 10 anytime in any time.
Mhm.
Uh,
Okay.
yeah.
Um, so explain to me what happens when you remove a random node in a heap.
The, when the time is expand.
Sure. So suppose that a timer on one of the requests has just gone out. That
Yeah.
request used to be number 5 on the top 10 list. So it's just somewhere in the middle of the heap. So what happens to the heap?
If the timer is expand, uh, we we can delete uh, we can delete the we can delete it from the heap and the linked list.
Mhm.
Uh, that's all, I think.
Sure.
Yeah.
Okay, so we're almost out of time. So suppose that it doesn't have to be completely accurate. Um, we can tolerate some inaccuracies. What are some things you can do to drastically reduce the memory requirement? Because right now we have to store every single request for the past hour, and then do a little bit of traversing to remove the older ones. What are some things that you can do to um, significantly reduce memory requirement, and you're allowed to sacrifice some accuracy?
Can you type it in the YY? Sorry.
Sure.
Okay. Let me see. I think, uh, in my opinion, I think if we if I use a heap, we can just to save the the top key, so space the using space is okay.
Mhm.
And I think the memory is memory is the lowest the lowest because it's just a okay space.
Mhm. What if we what if we simply bucket the requests? So rather than storing every single request, we only store the top 10 for the minute.
Uh, I don't know what you mean, and I think right now we use the okay space memory space, so I think
Mhm.
this is very low. Can I reduce it again?
Sure. Well, if we store only 10 requests per
Yes.
minute, then we only have 600 requests maximum. So the memory usage is 600 requests. That's much lower, right? And then since in order for a request to make it to the top 10 for the hour, it must
No,
make it
no.
to a
If we use we just the purpose of us is to get the top 10. So uh, we don't needn't to there's no necessary uh, to save the 600 data in the memory. We can
mhm,
we can use the heap to only maintain the top 10 data
mhm, mhm. Uh,
because yeah.
yeah. So what about the linked list? We need to store a lot more data in the linked list.
The linked list is just like the linked list of in the LRU cache, and the heap is uh, the linked list element is the same with the heap.
Sure. So if you're having an RRU cache storing all the requests for the past hour, that could still be a lot of memory usage, depending on how many requests you're getting. Um,
Yeah,
so
and if uh, the heap is, the heap's element number is k in any time and this uh, at any time the linked list element number is also the k.
mhm.
Yeah, so I think the memory usage is very low.
Mhm. Sure. Okay, I think that's fair enough. And I think we can conclude this question.
Okay.
We have about, let's see, 10 more minutes remaining. So let me ask you a more general question. So when you have a distributed system, or when you have a system that have a lot of components, just in general, talking to each other over the network, what are some of the considerations that must be given to each component regarding design or reliability or any sort of monitoring or production testing? So make sure that the whole system is as robust as possible.
Uh, can you type it in the YY again?
Yes, I
Sorry.
can do that.
Okay. We will conclude the consistency. I think this is the most important thing. Uh, first, we can use the if I some if if component A send a request to component B, and if we want to keep the consistency, so we must to let the component B respond ACK to the component A, and if we do this, we can keep the sequence of the orders.
Hmm.
And uh, And if the network is bad and some requests are lost in the network, um, so the component A will can't receive the response from component B. So the component A will send again the request to the B.
So retry mechanisms.
Sorry.
Sure. I was just saying that you mentioned retry mechanisms.
Okay.
Right.
And
how do you perform service discovery and announcements? When a new node enters the system, what does it do? And when a new node needs to find out about the rest of the system, what does it do?
And we will keep a heartbeat among the clusters, among the servers. So if the new servers is added, and he must set up a heartbeat with the other components, so the other components will know that a new node is added or done.
What if somehow the heartbeat mechanism cannot access one node, but that node is actually accessible by all other components in the system? It's just somehow the network link between the heartbeat mechanism and that specific node is out. How do we deal with that?
Can you repeat? Sorry.
Sure. So you'll have a heartbeat mechanism that pings each node periodically to make sure they're all up. Suppose that this mechanism detects that one node is not responding, so there's some kind of network problem between this mechanism and the node. So far, so good. Hello, are you there?
The node is not haven't responded, and what?
That's right. But turns out every other node in the system can talk to this node. It's just the heartbeat mechanism that cannot talk to the node. How do we deal with this kind of scenarios?
Okay. There are in this situation there are expired time to wait the response. If the time is out, we think and
So one simple way to do this is to actually make the heartbeat mechanism the same system as service discovery. So for instance, if you're using Zookeeper to keep track of the location of each node, as well as who is alive and who is dead, then if a node cannot talk to Zookeeper, then by definition, other nodes cannot find it, and therefore you can consider it to be down. And then you can link Zookeeper to whatever alerting mechanism you use to actually send out notice if anything is down. So that's sort of a simple way to by merging the two systems, you eliminate any inconsistencies. So yeah, I think we're almost out of time. Do you have any questions for me?
No, thank you.
Sure. Thank you very much, and have a good evening. It's like 2 a.m. there, right? Good night.
Good night. Thank you very much.
好，那开始讲解吧。首先我收到你简历之后我第一反应就你全是底层系统上的经验，我觉得你这方面比我专业很多，所以我不是很确定怎么面你。然后我就想，如果我面你这些专业上你懂的东西呢，其实就是陪你练英语了。然后既然会陪你练英语，
我不知道今天这是英语面试，我去。
这样的。因为这是美国的那个面试群，所以大家面试交流的专业交流基本上都是英语。对，因为面试官很少是中国人吧，一般都是貌似阿3比较多，其次是白人，偶尔才能碰到中国人。中国人也不可能中文面试。所以我就想，那索性就跟你聊一下 behavior， 就是聊一下你之前的项目，还有就是团队合作之类，然后再随便问个技术问题好了。总体就是我觉得你英语 发音先讲一下英语吧，英语发音蛮不错的，就是都能听懂，就是感觉不是很熟练，有些东西我明显觉得你应该知道，你知道你懂它是什么，你不太确定怎么说，然后就是卡在语言组织这个上面。
对，有些问题，然后没太听懂。
这个也可能是信号不好，然后可能你在那边我说话也不一定很清楚。之后看看具体问题的话，那个团队合作那个算是 behavioral 里面也算会问的问题吧，不是特别常见。基本上就是问你跟你队友时候发生争执怎么办？因为可能文化关系吧，在美国这边大家都会更坚持自己的意见，然后就工作中会有些技巧或者是一些核心的原理，要想一下怎么样。第一是解决这个问题，最好是能往你的方向走，如果你是正确的话。然后第二要保持两个人良好关系。所以算是这边的工作技能吧。然后问的你那个1个小时，就是top 10 latency 1个小时之内的 top 10。这个我当时想的是，你当时说是用一个 linked list，就是来存储所有1个小时之内的 request，然后用一个 heap 来代表这个 linked list 里面的 top 10，然后通过这个 linked list 来找哪一个要 remove 掉。然后我当时隐约记得，我很久没接触这个东西，我隐约记得heap 中间 remove 一个 node 不是很合适，然后我不是很确定。所以就没有讲出来。当初很久以前有别人问过我这道题，然后当时好像是告诉我不可以这么做，但是我确实忘了具体的，就算了。对，所以它也有些别的解法。就逻辑稍微复杂一点。但是总体还可以，就没什么大问题。其次的话，最后问你那个就相当于是很综合的 SOA 的东西。就比如说你有一大堆 node 的话，其实我在找的是像 logging、monitoring、production test、testing、service discovery。consistency，你这方面懂得比我多，好像是只有在多个服务器存储同样的数据的时候才会出现的问题。如果每个服务都是在存不同的数据的话，就是或者是说每一个服务都可能是自己的 cluster，那它就是服务内部自己处理这些就好了，然后整个系统的话，就可以假设每一个服务都是一个单独的点对点的 interface。对。所以其实我也不太知道怎么评价。总体就是多练一下吧，然后英语表达能力稍微再好一点。
好的。
对。其他就没有了。谢谢你参加这个模拟面试。
谢谢面试官。
对，我再说两句，就是说那个好的，我再说两句，就是我是 Steven，然后我个人觉得就是